In April 1999 at a Honda test facility in Tochigi, Japan, lead engineer Shigeyuki Uehara stood in front of a soundproof dynamometer cell, watching through reinforced glass as a prototype engine screamed to life. The tachometer climbed past 7,000 revolutions per minute, then 8,000, 8,500, and finally 9,000. The noise was unholy, a mechanical shriek that sounded like metal tearing itself apart. Every engineer in the room winced, waiting for the inevitable explosion. But it never came. The engine just kept screaming, holding 9,000 revolutions per minute as if it were nothing. Uehara checked the monitor and saw 0 valve float and 0 harmonics. The engine was producing 247 horsepower from just 2 liters, naturally aspirated. That worked out to 123.5 horsepower per liter, the highest specific output of any naturally aspirated production car engine ever built at that time. One engineer finally broke the silence, admitting that this shouldn't be possible. Uehara simply nodded, fully aware that according to every textbook, every formula, and every piece of conventional wisdom, what they had just built violated the fundamental laws of engine physics. At 9,000 revolutions per minute, piston speeds should destroy the bottom end, valve springs should float, and the harmonics alone should shake the engine to pieces. But Honda's engineers had read those books and decided that the laws of physics were more like guidelines. This is the story of the F-20C, the engine that shouldn't exist, the motor that rewrote what was possible from a 4-cylinder, and why Honda's own engineers called it the apex before intentionally making sure they could never build anything like it again. To understand why Honda built the F-20C, you need to understand the existential crisis they faced in the mid-1990s, which can be described as the NSX problem and Honda's identity crisis. The NSX, Honda's aluminum-bodied supercar, had launched in 1990 to critical acclaim. It was beautiful, reliable, and easy to drive, but it had one major flaw: it wasn't fast enough. The NSX's C30A V6 made 270 horsepower from 3 liters, impressive for 1990. But by 1995, the Ferrari F355 produced 375 horsepower, the Porsche 911 Turbo made 400, and even the Dodge Viper, a crude American muscle car, generated 450. Honda couldn't compete on power because they didn't have a V8 and they didn't use forced induction in their sports cars. Their philosophy was built around high-revving, naturally aspirated engines, valuing precision over brute force, but precision wasn't selling. The NSX became a commercial disappointment, beautiful, brilliant, and completely overshadowed by cars with bigger numbers on their spec sheets. Honda's management faced a brutal reality: their engineering philosophy, the very thing that defined their brand, wasn't enough anymore. Customers didn't care about VTEC or aluminum construction. They wanted horsepower, and Honda didn't know how to deliver it without abandoning everything they believed in. Then someone had an idea. What if they took their high-revving philosophy to its absolute extreme? Not just high RPM, but impossibly high, so high that the specific output would shame every competitor, even the Ferraris and Porsches with their exotic V8s and V10s. They couldn't build a big engine, but they could build the most advanced small engine in history. The project was called Dream 2000, with a mission to create a 2-liter engine that would rev to 9,000 revolutions per minute and produce over 120 horsepower per liter, something nobody had ever achieved in a production car. When the brief hit the engineering department, most people thought it was a joke because 9,000 revolutions per minute was Formula One territory, and production cars just didn't rev that high. They couldn't, as the mechanical stresses would destroy the engine in hours. But Uehara, the man who had led NSX development and revolutionized aluminum chassis construction, believed it was possible, and he assembled a team of Honda's most brilliant engineers to prove it. What they were about to attempt would require reinventing almost every component of a traditional piston engine. The first problem they faced was basic physics, piston speed, a problem nobody could solve. When an engine revs, the pistons move up and down, and the faster the engine revs, the faster the pistons move. This is called mean piston speed, measured in feet per minute or meters per second. For most production engines, mean piston speed tops out around 4,000 feet per minute, considered the safe limit before mechanical stress becomes dangerous. Racing engines push to 4,500 or maybe 5,000 feet per minute. At 9,000 revolutions per minute with an 84mm stroke, the F-20C's pistons would be moving at 4,960 feet per minute, faster than most Formula One engines of that era. At those speeds, several bad things happened simultaneously. First, The connecting rods experience massive tensile and compressive forces, being stretched and compressed thousands of times per minute with enough force to literally rip them apart. Second, the piston rings can't seal properly. As, at extreme speeds, the rings flutter and lose contact with the cylinder walls, causing compression to drop and oil to get past the rings while the engine loses power and starts destroying itself. Third, the valve train can't keep up because valve springs, even strong ones, can't close the valves fast enough, causing the valves to float and stay open when they should be closed, which leads to catastrophic collisions between pistons and valves. Every engineering textbook said the same thing. You can't safely rev a 2-liter 4-cylinder to 9,000 revolutions per minute with a production-viable lifespan. Honda's answer was simple. Watch us. The valve train was where Honda performed their first miracle, creating what could only be called an impossible valve train. To rev to 9,000 revolutions per minute, they needed valves that could open and close 75 times per second without floating and without breaking. The F20C required hand assembly, exotic materials, and obsessive quality control, and it lost money. Modern engines are designed for profitability first and performance second. They're built by robots on assembly lines using common parts to reduce costs. They are good engines, but they are not the F20C. What Honda won't admit publicly is that the F20C was a glorious, beautiful mistake. So, they built an engine that was honestly just too advanced for its market, too demanding for its drivers, too expensive to manufacture profitably, and, well, too uncompromising for everyday use. But to enthusiasts, the F20C represents something way more important than just profit margins. It really stands for the moment when Honda asked themselves how far they could push naturally aspirated technology. They built an engine that revved all the way to 9,000 revolutions per minute and could last 200,000 miles doing it. Will we ever see another engine like the F20C? Probably not, because the economics just don't work. Turbochargers are more efficient, and most buyers these days really don't want to rev an engine to 9,000 revolutions per minute just to access full power. The age of naturally aspirated, screaming 4-cylinders is over, and the F20C was honestly its final perfect expression. Here's the question Honda can't answer. If they could build a 9,000 revolutions per minute engine back in 1999, what could they build today with modern materials and technology? Could they actually build a 10,000 revolutions per minute engine? Could they extract 150 horsepower per liter, naturally aspirated? Or have they just decided that chasing that dream simply isn't worth it anymore? Was the F20C ahead of its time, or was it really just the last of its kind? Drop your take in the comments. Was the F20C the greatest 4-cylinder ever built, or was it just an over-engineered dinosaur? And hey, if you owned an S2000, would you keep the F20C stock, or would you be tempted to see what it could do with a 9,500 revolutions per minute redline? When the F20C finally debuted in the Honda S2000 back in 1999, the automotive world was, honestly, just stunned. Here was a production roadster with an engine that revved higher than almost any production car in history, produced more horsepower per liter than even Ferrari's finest, and did it all without turbochargers, superchargers, or any exotic materials that would make maintenance impossible. The S2000 wasn't just fast, it was a whole experience. To really drive it properly, you had to keep the engine singing above 6,000 RPM, shifting at redline to stay in the power band, and working the gearbox and clutch with real precision to keep the engine on the boil. It rewarded skilled drivers with breathtaking acceleration and punished lazy ones with some pretty disappointing performance. It was an engine that demanded engagement, that actually asked you to participate in the act of driving, rather than just pointing the car and pressing the accelerator. But the F20C's brilliance honestly extended way beyond its power output. It was remarkably reliable for such a highly stressed engine. Owners regularly reported 100,000, 200,000, even 300,000 miles from engines that had been regularly abused at 9,000 RPM. The secret was in the engineering. Honda had built the engine with enormous safety margins, designing components to withstand stresses far beyond what the engine would ever experience in normal operation. The connecting rods could handle forces that would snap lesser parts, and the cylinder block was rigid enough to resist harmonics that would shake other engines apart. The valve train, so carefully assembled, would run for hundreds of thousands of miles without adjustment if it was properly maintained. It was over-engineering in the finest tradition, building something not just good enough, but honestly far better than it needed to be.